Hello, all you poster viewers. My name is Allison Bruning, and I am a third-year graduate student working in the Lewis Peacock Lab at the University of Texas in Austin. This project begins with the idea of optimal use of working memory resources. Previous work has shown that the limited resources of working memory are flexible in that we can distribute these resources unequally to items. And not only this, but that we use this flexibility to optimize our limited resources to minimize errors. But how we use working memory in everyday life is much richer and more involved than the typical delayed estimation task. Working memory has access to other forms of information that may not come from an external source, such as our behavioral goals, our uncertainty of information, and even information in long-term memory. In these example experiments, resources were optimally allocated and decisions were optimally made to either minimize errors or maximize reward. In this experiment, we ask whether goal-relevant information in long-term memory also influences how participants allocate their working memory resources. We hypothesize that participants will prioritize encoding items with no long-term memory information and rely on prior information to guess when applicable. We have participants remember and report the locations of all 6 items on a screen. To incorporate long-term memory information into this task, we had one of the 6 items always appear about a particular area on the screen, while the remaining 5 could appear in any location. We refer to these items as the prior and non-prior items. The color and location of the prior was randomized for each participant and was shown once at the beginning of the experiment. Participants would complete practice trials until they could sufficiently report where the prior item would typically appear. Throughout the experiment, participants were again asked to report where the prior would typically appear. Here we have a distribution of those responses where 0 is the mean of the location distribution for the prior, indicating participants maintain this knowledge throughout the experiment. The first result shows that participants do in fact use prior information. Here we see the error distributions across all subjects for both prior and non-prior items. We can use resultant vector link to summarize the precision of these distributions, showing that the prior item had greater precision than the non-prior items. When we break these distributions down by response number, we can see the difference only exists in the last 3 responses, indicating prior items do not have more precise memories, they just have more educated or precise guesses due to the prior information. Also important to note here, we've replicated previous work showing participants report items in order from highest to lowest precision. This relationship is an important indicator of prioritization, where items reported first receive greater resources. So when are the participants reporting the prior item? We can definitively say that they're not uniform, and there is a bias to report the prior item later, but it's not heavily biased to the last response like we may have expected. We propose that participants are keeping to the order of highest to lowest precision, where educated guesses about the prior have lower precision than responses for items in memory, but higher precision than non-prior guesses. So this response to the prior item may be marking a boundary between responses in memory and guesses. If this is the case, responses to non-prior items before the prior item is reported would have higher precision than those reported after the prior item. And this is exactly what we find. When we control for response number, we find that items reported before the prior have greater precision than after. Finally, because the prior information is spatially bound, we wanted to test whether response error was influenced by where an item appeared on the screen. First, looking at the non-prior error, we see that items that appeared near the center of the prior distribution had greater error than anywhere else, indicating participants are allocating fewer resources to this particular location. Next, looking at the prior error, the effect is the opposite, where error decreases at the center of the prior distribution, indicating participants are using the prior information to report the location. Where if the participant always reports the center of the prior location, then prior items that appear near this location would have less error. Consider alternatively, if participants were attending to this area, we'd expect the non-prior items to decrease in error at this location as well. Or if participants were attending to prior items specifically, we'd expect the error to be the same regardless of location. Also note that these data do not extend past 60 degrees from the center because the prior does not appear outside of this location on the screen. In conclusion, we show that participants do make use of long-term memory information, and that they are able to do this by attending away from where the prior item typically appeared. Critically, this came at the cost of increasing error for non-prior items in this location, demonstrating that the incorporation of long-term memory optimizes resource allocation, but does not increase capacity. If you have any questions, please feel free to email me or use the live chat during the poster session. Thank you so much for watching.